Hello, everybody. Welcome. Good morning, good afternoon, good evening, depending on where you are in the world and you're joining us today. Regardless, thank you. Thanks especially for joining today for today's webinar, which is Unleash Collaboration with the new ENVI and IDL Repository. My name is Cleo Megron, and I am your host and co-presenter today. Both Zach and I are product managers here at ENVI Geospatial, and we both manage the ENVI ecosystem, and we're both really excited that you could all join us for today's webinar. Next slide. So just a few housekeeping items before we begin. This webinar is being recorded, and we will send you a link to the recording along with today's slide deck in the next few days. If you'd like to access the slides right away, they will be available in the handout section of the webinar dashboard. All attendees are going to be muted, but if you have any questions during the session, please enter them into the questions box and we will have a Q&A session at the end. Next slide, please. I am very excited to introduce today's primary speaker and presenter, who is Zach Norman. As I just mentioned, he is another product manager here at ENVI Geospatial. Zach has been with the company for more than 10 years, and he brings deep expertise in our products, as well as a very clear vision for how they can meet evolving industry needs. Today, he's going to walk us through how the new ENVI and IDL repository enable powerful collaboration, streamlined workflows, and much faster innovation. With that said, I'll turn it back over to you, Zach.
All right. Sounds good, and thanks for the intro, Khalil. And not to downplay Khalil's participation, but we'll probably be almost 50-50 for content today. So Khalil and I are going to tag team showing some of our workflows live, and kind of with that, talking about our agenda for today. This webinar is going to be a little bit different than some of what we've done in the past. We've got about 15 minutes of slides, 10 or 15, depending on how fast we talk. And then most of our time will be spent in demos. So we really want to focus on showing this technology working, which is where Khalil and I will come in, because we're actually going to publish and share content and run it for me and for Khalil as well. So we're going to go through some background information just to set the stage a little bit for where we've come from and what's brought us to the ENVI and IDL repository, and we'll introduce that concept. Then we'll go through some of the workflows with ENVI and IDL and with machine learning and deep learning models using ENVI. And last but not least, in the spirit of improving collaboration and kind of lowering the barrier for ENVI users, Khalil's going to introduce a work in progress called GeoAgent that we first kind of announced or teased at the Esri user conference just about a month ago. So with that, we'll go ahead and get started with our background. So hopefully everybody knows by now, or most people know what ENVI and IDL are. Starting with ENVI, just in case you are brand new here and this is your first time listening to this recording or joining our webinar. ENVI is a tool set for remote sensing and image processing and image analysis. It's been around for a very long time, has a rich history with lots of support for different types of data and data modalities, with a primary focus on spectral and SAR, but it works with panchromatic, multispectral, or LiDAR or DEM, DSM data sets as well. And because we have been around for quite a while, we have a really broad suite of tools, from traditional remote sensing algorithms and techniques to more advanced machine learning, deep learning, and kind of latest and greatest technologies there as well. Behind the scenes with IDL, behind the scenes of ENVI, we're powered by IDL, which is an array-based programming language, great for image processing, image science, data analysis, and visualization. One of the big features of IDL is we have native integration with Python, which we'll talk a little bit about today and some of the changes with the latest version of IDL. And one of the other benefits of IDL is it's got direct access to ENVI's API, so it makes it easy to create custom image processing workflows as well. So those are the two pieces of tech that we'll be talking about, we're spending most of our time in today. But to set the story and change our narrative, we want to make sure we talk a little bit about how we kind of view our software and some of the problems that we're trying to solve ourselves that we think will provide a lot of value to ENVI and IDL users. So some of you may have seen this slide before, but really kind of the gist of this is that depending on the type of user you are, we have different software solutions that can help you out, right? If you are a technical user and a programmer, you can be all the way on the top right with IDL and the ENVI API. If you just know how to use ENVI and are familiar with remote sensing, we have user interface workflows, multi-step processes that you can go through where you don't have to program. Or at the other end, if we're in ENVI Inform, we can just deliver answers to ArcGIS Online for kind of near real-time monitoring services so that you don't have to worry about everything that happens behind the scenes. And as part of this, the way that I like to think about as kind of like two buckets of users or consumers of content, where you can have people who are subject matter experts or more familiar with remote sensing, image science, image processing, or data analysis, creating analytics or analytic content on the left. So we can have collections of image processing workflows or IDL code, which then needs to be exposed to either other users or other pieces of software that we have over on the right-hand side. And for us, especially over the last 6 to 9 months, we've really been going through some growth of our own for how we want to make it easier to take things that someone like myself would create in our organization and make available to others within our team or be able to run automatically in our cloud processing platform. And that's where we get to the main topic of today, which is the ENVI and IDL repository. So the repository is a new capability that lets users create their analytic-based content. They can publish it where other users can go search, discover, and install and utilize immediately in their own instances of ENVI and IDL. Kind of like we had on the last slide, we have things like ENVI modeler workflows, collections of IDL code, and different types of AI models, including Onyx, which we'll talk about and introduce a little bit more later on in our presentation. So really the core concept here with the repository is that users can create content that they can publish and share with other people in their organization. So the kind of two places that we really utilize this the most ourselves, and we have a couple of workflows with ENVI and IDL that'll kind of be the focus for today, is that ENVI number one is that you can create an image processing workflow using the ENVI modeler. And what we'll show is that me, as user number one, I'll create that workflow, I'll publish it to the repository, and then Khalil will download, install, and run that on his machine. So we'll illustrate the multi-step process of me creating something that runs on my machine, Khalil accessing and utilizing that himself. And we'll also go through that same process with an IDL package. So we'll create an IDL package, publish it to our repository, and then show how you can download, install, and utilize that within your session of IDL. So if you're not a programmer, don't worry. We're not going to be spending a lot of time in code or some of our examples there. We'll just show the basics and keep it at a high level. So these next couple of slides, I'm going to go through pretty quickly because we're going to show most of this live. I just want to make sure we have a little bit of a reference information as we're going through the ENVI user interface with some of the capabilities we'll show. So utilizing the repository within ENVI, there's two places that you can access this information. The first is the top left of the ENVI UI, where we have this little share button that also can be found within the ENVI modeler. In this little drop-down, you can add ENVI repositories, you can browse what's available, you can also install and run any tools that you have available to you. The other side of this workflow within the ENVI UI is directly inside of the ENVI modeler, where I can create a workflow, I can go through that share menu, I can publish, specify a little bit of information, and then that workflow will exist on the repository where other users can download and install. Again, we're going to walk through this with Khalil here in just a couple of minutes. Next, when it comes to IDL, we're going to showcase the two-step process for creating an IDL package and then publishing that package to the repository and showing how you can search and discover and install that to use in your session of IDL. As part of our IDL workflow, we're also going to show the web UI that belongs to the repository, which offers an alternative to the ENVI desktop repository browser that you'll see here in a little bit. Last but not least, one of the things we want to make sure we call out today is that to utilize the ENVI repository functionality that we're going to show, the assumption is that within your organization, you'll have an instance of the repository as a server up and running that you can access. So Khalil and I are both on the VPN for our Works network, where we have a demo repository server stood up, and that's what we're going to be interacting with. This is really important to call out because if you're a part of an organization and you want to utilize this functionality, that's something that you'll have to go through and set up yourself. So with that, just checking time, make sure we're good. We're going to pivot to our first set of demos here, where we're going to show our ENVI modeler workflows and IDL packages. So let me come over to ENVI and we will make sure I get my display set up, and we'll open up the ENVI modeler as well. So for our ENVI modeler workflow example, what we're going to do is I have a workflow that I created that detects burn area between two images. So I'm going to navigate to the folder where I have this workflow. So I have a burn area detection .model file. These .model files are ENVI modeler workflows. To open them up, you have a couple of options. My personal preference is to just drag and drop directly into ENVI, where it will pop open. And to showcase this, we have two sample data sets that we'll be running through this workflow. I have a pair of images. If we pop back to ENVI's display here, I have a pair of images that showcase or show the damage from the fires in LA that were earlier this year. This is near the Pacific Ocean, and if you look at these mountains towards the bottom of my display, and if I toggle my layers on and off, you can see where it's visually where vegetation no longer exists. So our burn area detection workflow is going to use a spectral index, compare time 1 and time 2, apply a threshold, and then do a little bit of classification cleanup. So I'm going to go ahead and run this here on my machine just so you can see it working. And then we'll publish this to the repository where Khalil will show us the browser and how to download and access this. So this takes about 30 seconds or so, same for the demo data set that Khalil has. And I guess the one thing I'll say about this is that for like burn area detection or change detection in general, it can sometimes be a complicated topic. And depending on your data or the environment, or just the collection or the conditions when the imagery was collected, not every change detection workflow may work best for your data. One of the things that we do have within ENVI is a step-by-step change detection workflow. If you go through the interactive workflow in ENVI, you can actually create an ENVI modeler representation of the steps that you manually went through. So this is a really nice way for you to basically automate the steps that you went through using your expertise and looking at each individual step of the process that you can then publish and make available to other users. All right, took a second, but if I open up ENVI's data manager, which my computer's going nice and slow today, just in time for demos. I'm going to go ahead and adjust the transparency a little bit and my layers so that you can see that our results do a decent job. It's maybe about 80 to 90% depending on the data set. So yellow is the burn area that we detect. And this is the image, where if you look at some of the darker brown and light brown areas in the mountains, that's where you can visually see some of the burn area. So point being, here we have a workflow. I manually created this, but you could also generate one of these by going through some of the workflows in ENVI's toolbox. And now I'm going to share this so Khalil can run this himself. If I go back to the ENVI modeler user interface, we have share in the top left. I'll click on publish to repository, which is where I'll have the option to specify the name, display name, and a couple of other pieces of information. One of the things I want to call out here is that there is a pattern we always follow for the name and display name. Display name is something that's typically human readable. Not that the name is not human readable, but we have spaces between our words, and then our name, we usually just remove all the spaces from the display name. This follows the pattern for a lot of ENVI's tasks out of the box and the tools that you'll use within the ENVI modeler. All of this information here exists when I opened up the publish dialog, because I published it before. We save that information to make it easy for you to make updates and publish new versions. So I'm going to hit OK, and this will publish the workflow to the repository. Our ENVI modeler workflows are very small, so this happens very fast. It takes a second for this to go up there. And now we'll switch screen share over to Khalil so that he can show the other part of this workflow.
All righty. Let me know when my screen is coming up, Zach, if you don't mind.
All good. We can see.
Awesome. Thank you very much. So I'm actually going to be operating on this screen. So if you see me facing this way, I apologize. I'm just looking at ENVI. And what I really want to call out that I think is really exciting, I think, and important about this ENVI repository capability, or ENVI and IDL repository capability, is the fact that, my background's in SAR, but the fact that it enables people that have my background and somebody that has Zach's background to work together is really awesome. So I can click share, and then I can click that browse ENVI repositories button, just similar to that same workflow that Zach just highlighted. And then I can see that that same analytic or that same workflow that Zach uploaded is actually present here as well. So we're going to go ahead and install it. And before I run it, we're just going to do a very quick kind of just visual look, so you can see the actual extent of the damages. I believe this is planet data or
PlanetScope data.
PlanetScope data. Thank you. So let's go ahead and pull up that. Where did it go? It's right here. There we go. Burn area detection, and we'll pick my time 1, and we'll pick my time 2, and we'll go ahead and make sure display result is checked. And just like Zach mentioned, same extent, similar data, so it should take approximately the same amount of time to run. But really what I'm looking for here is just to see how well it maps out the actual extent of the fire, right? So we can test whether the analytic was successful or not. And I think it did a pretty good job, just like how Zach mentioned, at mapping out the actual extent of the imagery that was actually burned. So point being is we are essentially looking to help enable new workflows across our broad set of users that leverage the ENVI ecosystem. And I think the repository helps enable a lot of those exciting capabilities. So I think that's it, Zach.
Yeah, maybe one thing before we switch back. Can you pop open the repository browser real quick? And just to show, because this happened very fast, if you go to the installed packages, so once Khalil had downloaded the package, it popped up the dialog, but you can also open the tool from here.
Got it. I see. So I could have also just clicked. Okay, perfect. See, I didn't even know that. Now I'm learning. So awesome. Thank you, Zach.
Yeah, sure thing.
All right, back to you.
All right, cool. So let me steal screen share and we'll pop back over. Okay. So the next thing that we're going to show, following my little script here, is we're going to walk through what this looks like for an example IDL package. So for IDL packages, we have a similar but slightly different approach for how we collect everything together and publish it to the repository. first things first, and let me make the text a little bit bigger here. In Visual Studio Code, I have a folder open. This is my IDL package demo directory. Inside of this, I have sample data, and I have a couple of profiles, that's IDL code, that I'm going to package and share. The code in here isn't doing anything too fancy. This is a spherical transform demonstration, which takes just a second to run, and shows some of the new functionality added in IDL 9.1 for other ways that you can process your data to remove noise. So I have some code that I've air quotes written, and I want to publish that and share, make available for other users. The first step to do this is creating this IDL package.json file at that root level of a folder that you'd like to share with other users. The JSON file itself is pretty small, very easy to create on your own. If you're working from Visual Studio Code, you have autocomplete and hover help for all of these fields, which makes it very easy to set this up yourself. Alternatively, we do have an API called ipm.create, which will set this up for you the same way, and then you can fill in or change some of the fields once you have the JSON file created on disk. So the hardest part about an IDL package is creating the logic and the routines that you're going to be sharing with other users. Once you have this, you can run a single command, which we have in our little script on the left here, where we have ipm.publish, and you'll give it the path to the folder and the name or the URL for the repository that you're publishing to. If you imagine for a second, just in case you are not an IDL programmer or haven't used the routine dir function, all that this is doing when I run this is it's just automatically adding in the path to this folder here. So routine dir is a shortcut for all the text that I just pasted in here. So just makes it a little bit easier to read, but that's effectively what it does. So I'm going to go ahead and run this script, which will package up and publish everything that's in this folder for me. When I hit run, if we look in our debug console here, you'll see we have some progress messages and then a final message that says, oh, the package was uploaded to our repository. So creating IDL packages, I think very easy. You do it once, you have this checkpoint basically, you bump your version the next time you want to publish and rerun the exact same command. So once you have your code written, packaging is pretty easy. So the other piece we want to show here as an alternate to the ENVI user interface for the repository browser is we have the web UI as well. So I just refreshed so that we would have the burn area detection and IDL package demo showing here as well. Within this user interface, you can search by name, different types. So these are the types of packages that have been published or any of the tags that are present. You can also manage your packages and delete them if you want. You can download the package directly, or you can click this handy little install on desktop button. So when I click install on desktop, your browser is going to prompt you if you want to open up the application. When I click open, IDL is actually going to handle that URL and it will install that package on my machine. So this is really nice, and this works for ENVI and IDL packages. It's really nice because it helps dramatically streamline the installation process. If you are in a browser, you don't have to be in ENVI and IDL directly. You can go from the browser if you find that to be more convenient than some of the other tools that are provided. So once that little dialog finishes installing, it disappears. And if I come back over to IDL, I can run one more command called ipm.list, which will list the packages I have installed. And we'll see that I have the IDL package demo version 1 here, in addition to my cloud detection package. So if I run spherical transforms directly from the command prompt or IDL command line here. We'll have the same graphic pop up as when we manually ran this earlier. So that's just to illustrate the workflow for creating and installing IDL packages using our browser instead of IDL APIs. One of the things I want to make sure to call out here is that this cloud detection package, while this is an IDL package, this is actually has custom ENVI routines and some ONNX models that are included as part of it. So IDL packages are for much more than IDL. You can have pretty much whatever you want included in those packages. So like for this demo, I have a couple of PNGs. You could have some other little small sample data sets or other things. So that's our first demo showing the package publish and install workflow for ENVI and IDL. We're going to jump back to just a couple of slides. Make sure we're good on time here. Go back to a couple of slides and then we'll show our next demo. So let me get back in presentation mode here. Okay. So the next half or second half of our repository workflow, we're going to be talking about AI models. Part of this, we've been developing the next version of ENVI Deep Learning, and as part of this release, we've been upgrading a lot of the technology that we're using behind the scenes to make sure we're using, state of the art or latest and greatest for what many people are working with today. As part of this, we use ONNX models now for all of our classification workflows. So when you train a model in ENVI Deep Learning, you'll get ONNX models at the end. And for those that don't know, ONNX stands for Open Neural Network, this is covered up, Exchange, and it's a standard AI format that, depending on, regardless of if you're using something like, PyTorch or TensorFlow, you should be able to export and convert your models to ONNX at the end. So then you can train using the tools that you've created. If you're an expert, then you have the full flexibility of, accessing like Python directly. And there's two reasons that we're spending some time talking about ONNX. The first one is that this allows you to bring your own ONNX models into ENVI. So our support for ONNX allows you to configure pixel or segmentation models and object detection models. We'll show this here in just a second using our cloud detection IDL package that we just talked about when I was over in IDL land a second ago. The other reason that ONNX is really important is that as part of everyone's ENVI license, you'll have access to processing data with ONNX models in ENVI. So we're really wanting to help facilitate people bringing content into our software, utilizing the repository as a central place to publish content that anyone can download, install, and run. So really big change for ENVI. And just to talk about some of the workflows that are enabled with deep learning and the repository is that we're going to start with the middle one here, and then we'll talk about machine learning. So within ENVI, we have a special tool that lets you configure ONNX models to run within ENVI. Once you've configured an ONNX model, we'll typically create a paired ENVI modeler workflow to prepare data for analysis before processing with the model. And you can publish the ONNX model and the ENVI modeler workflow to the repository where other people can find, download, and install. Machine learning operates the exact same way, except for the configure part. So you'll train a machine learning model within ENVI. You can publish that machine learning model to the repository where other users can download and run. So we're going to show part of the middle workflow, and then we'll show the bottom workflow as well today. So I'm going to jump back over to ENVI where we will keep our demo moving. So before I show anything, I'm going to close all the images that I have open in ENVI, and I'm going to pop open a sample data set here. And my computer is going really slow for the demo. So this is taking just a second, way longer than it should be, which I guess is what we get for live demos. All right, so here I'm going to open up the clouds image. Okay. Sorry, this is going very, very slow. I restarted my computer to make sure it wouldn't do this today while we're doing demos, but here we are. Okay, so I've got my image open for showing cloud detection. I really like using this as a sample image because we have clouds in the top left and we have snowy mountain peaks in the lower right. So it illustrates how the ONNX model that we grabbed that's open source works within, or how well it works. So within ENVI, the cloud detection IDL package that I have installed has a couple of custom tasks that are a part of it. These custom tasks within ENVI, if you search in the toolbox for run task, that's an easy generic way to run just about any tool that ENVI has available, even if it doesn't show up in the normal toolbox. So from this dialog for run task, if I search for cloud, there's an entry here for multispectral cloud detection, and I'm going to open this up. So this is, like I mentioned, an ENVI task that's contributed from an IDL package. And as part of this, we have some ONNX models that are used behind the scenes to actually detect clouds. For this algorithm, there's a couple of options. The one that I want to call out here is that we have this use Python. So this is here as an example to illustrate that with ENVI 6.2 and IDL 9.2, we're actually including Python out of the box. So you have an instance of Python that you can install your own packages to. So if you wanted to set up, PyTorch or TensorFlow or other open source Python libraries, you can do so and then access those directly from IDL. So I'm not going to use Python because it's a little bit slower than ONNX. I'm just going to go ahead and hit OK to have processing get kicked off. You'll see a couple of progress dialogues appear, and then we'll hit the ONNX pixel classification. So this is where we're actually running the ONNX model to process this image. Like I mentioned when we were in the slides, as part of integrating AI models into ENVI, there's potentially other processing steps that need to happen. So one of those examples for cloud detections is we make sure that images have the right spatial resolution to match what the model trained on, and we pick the right bands from the data set so that the model gets the data that it expects. For example, if an AI model was trained on, say, RGB data, and if you have a 4-band image, you want to make sure that you pluck out the red, green, and blue bands and pass that to the model instead of, say, a color infrared band combination. It only takes a second to run, and if I come back over here to ENVI, I'll adjust the transparency for my display so that we can see where the clouds are and then what the ONNX model detected. I'll toggle this a couple more times just to make sure that you can see it, and it does a very good job. So again, this is where the flexibility of ONNX really has a lot of potential because we can bring different AI models into ENVI. We have more access to Python, so we can use open source algorithms as well if we want. And then we can publish the AI models and custom workflows to the repository so anyone else can access and use them. Okay, so that's our first AI demo. The next one we're going to show here before we hand it over to Khalil is we're going to talk about machine learning and publishing. So again, my ENVI is taking its sweet time today. We'll give this just a second. So the next demo that we're going to show is a land cover classification. And what I did was I created a kind of proof of concept land cover classifier for Sentinel-2 imagery. It uses all of the 20-meter bands, and I think it's got 8 bands total from our visible to some of the near infrared and slightly longer wavelengths as well. And I have a sample image here that I'm going to open up and adjust the stretch on because it makes the water look really nice and pretty. So with this sample image, we're going to process just a little subset with the machine learning model so that processing doesn't take too long. And what I'm going to do is I'm going to come over to our ENVI repository and show you the model that we're using. So I forgot to, hold on one second. I forgot to uninstall this earlier. So I'm going to uninstall the AI model and then reinstall it. So I have the Sentinel-2 land cover classifier, which lives in our repository. This is 2.5 megabytes, so it's really quick and easy for me to download. If I click install, we'll have a little dialog pop up. Takes a little bit longer than when Khalil was showing the ENVI modeler workflow, just because we've got a little bit more data coming. That's part of the reason we're not showing some of the Onyx model download or publishing live, because it takes a few minutes depending on the internet connection. But once I have it installed, it shows up here in my list of other packages. From these other packages, you'll see these ENVI Deep Learning Onyx model types. These are some of the other Onyx models that I've downloaded from the repository that we published here for our demonstration. Before I run the machine learning model, I do want to pop open a couple of dialogues here in ENVI just to show you what publishing looks like. So let me get these dialogues open. So we have dedicated toolbox entries for publishing the Onyx models that have been configured to run in ENVI and publishing the machine learning models. These dialogues, very easy to populate. They are almost the exact same as the ENVI modeler published dialogues. So you just need name, display name, description, and version. So pretty easy to go through and publish. Once you have, they show up in the list like I'm showing here. So I'm going to open up our machine learning classification dialog, and I'm going to navigate to get a spatial subset that matches my display. So in our data selection, I'm going to open up spatial subset, and I'm going to pick the area that my view is focused on, and then I can actually zoom in inside of the spatial subset, and I can fine tune or adjust this if I want. So I'm going to pick an area that's a little bit smaller since my machine seems to be going slow right now for demos, and we'll hit OK. And then I have to pick the machine learning model that I want to process with. So one of the really cool things about how we've integrated the repository with machine learning and deep learning is that you have a data manager now anytime you're picking an AI model. The data manager knows what you've downloaded from the repository, and you'll see here I have the Sentinel-2 land cover machine learning model, that's random forest, available and easy for me to access. You'll see it gives you a summary of the number of bands that it requires and lists out the class names that it detects as well. So this is the only one I have installed, so I'm going to just go ahead and hit OK, and we'll let processing run. So one of the things I'll just call out again, hopefully to get this to stick, third time's the charm, is that when you are publishing AI models, just be aware or thinking about, is there other pre-processing that needs to come along as well to make sure that other users can be successful working with the Onyx model or machine learning model. For machine learning with random forest, I already pre-processed this image to match what the model expects, but you may need to help create that or document the steps for users to go through to be able to utilize some of the analytics or algorithms that you create. So now that it's back, if we look over here in the layer manager within ENVI, you can see all of our classes that we've detected, and overall it does a decent job. There's probably a little bit of confusion between forest and vegetation here, and so we could go through and maybe edit or clean up our classification image. But let me just check my notes. I think that's everything. And yep, we should be good. So, all right, with that, that concludes our ENVI repository portion of our kind of demos today. We wanted to make sure that we could show how you could utilize it with ENVI modeler workflows, IDL packages, download and install packages, and use them with our different flavors of AI models. So next we'll pivot a little bit to GeoAgent, where Khalil's going to introduce some of the concepts on how we're trying to lower the barrier in a similar way to the repository to make remote sensing more accessible.
Thank you, Zach. Yeah, actually, it's actually a really fascinating segue, I think, because what you just demonstrated was a lot of really exciting, cool new capabilities coming to ENVI, and that's awesome. So GeoAgent, what this is, just a little bit of context, if you've never heard of this or haven't been to our web page and seen it, it's our phased approach to tackling, or to connecting AI and geospatial together. Our first phase was actually a target date at the Esri user conference this last summer, and we had tremendous feedback to what GeoAgent was doing and how it was performing. So what GeoAgent is an AI-based chat interface for all of your geospatial systems. The vision moving forward for MD5 Geospatial with our AI strategy and what we want to do with GeoAgent is to make sure that it's a tool that can help you streamline the process of executing tools and tasks, as well as learning how to do your job. And what I think sets us apart from maybe some of the other new advancements in the AI space is we truly want to take our ecosystem and extend beyond what is available to you in just ENVI. So we want to highlight integration with Esri and beyond. We want to integrate with other endpoints and other entry points into our ecosystem. So this first phase prototype that we put together that I'm about to demonstrate has the ability to create tool chains and execute them on your behalf. If you do want to learn more about GeoAgent, there is a landing page and you can follow the link at the last bullet there. I do want to caveat that this is currently not a product. This is a solution we are targeting to have as a full iterative product in the future. But right now, it is essentially a prototype that is connecting a large language model, our ENVI goodness, we'll put that, our ENVI ecosystem, and it's using a common infrastructure in the AI world today, such as MCP, to accomplish some of these goals. Next slide, please. So for today's demonstration, we're actually going to be walking through a workflow where we're going to be doing some mineral mapping. Now, this industry is a global industry. I think many of the people that use ENVI potentially even work within this industry and you love using ENVI tools to solve some of the problems that we can solve with our tools in this industry, right? So in this instance, we're actually going to be doing mineral exploration over Mountain Pass, California. And more specifically, we're going to be looking for neodymium, a rare earth element, which is utilized in the production of magnets for electronics. This is again, global problem, but what we want to show is how we can use GeoAgent to link multiple tool chains together, use a set of data that we found, and host a lot of these things in an S3 environment and see how it operates and compare that to how doing this work by hand, how long that would take. By hand, this is on average at 35 to 40 minutes. It's a material identification workflow. Let's see how long we can get this done with GeoAgent. So with that said, Zach, would you mind passing screen share over to me? We're going to jump over to the GeoAgent user interface. There we go.
Should be coming your way.
All right, let me know once you can see my screen.
Yep, coming through.
Okay, thank you. All right, so this is the user interface we have put together for GeoAgent. A few caveats with this. This is a user interface that makes sense for the phase one approach that we put together, but we understand and are very flexible with the idea that this can grow and look in many different ways. But we wanted to explore the art of the possible, so we thought, why not just start talking to an agent that has the ability to access ENVI tools and ChatGPT 4.0 behind the scenes. So that's what we're doing. So in this case, I just copy a prompt because I type a little slow, but I am a spectral analyst working to detect minerals over Mountain Pass, California, as mentioned. And I'm actually asking GeoAgent to find both relevant data, imagery, and a vector mask that is actually located in my resource folder. This resource node is just an S3 instance in this case. So let's see if GeoAgent is able to find the imagery. And it looks like to find the imagery, it's basically asking me for a bounding box. So I can provide a bounding box if I have one, so I can make one, or I can ask it to just estimate one, please. And let's see if it's able to find the imagery with an estimated bounding box. I am hoping that it can, because there's not a whole lot of data in my resource folder right now. So let's see. All right, it's gone through the estimation. Now it's going to be searching for raster imagery and vector data, and boom, there we go. So essentially, we are able to use an AI tool to parse through a resource catalog. Okay, next. From within the user interface, we're able to explore some of the data, right, that we've already preloaded. We can even make this full screen if we want to do some actual exploration with a different base map, for example. Here we have that Avaris next-gen image, and the image is still streaming in tile by tile, but you can probably start making out slowly that there's actually an open pit mine right here in the center, and there's going to be some deposits around it. Actually, there we go. So now we can zoom a little bit closer. So I think that this data is satisfactory for the work that I'm trying to do, and therefore I'm going to tell GeoAgent to proceed with that. So my job, if you recall, is to find neodymium. So I'm going to tell GeoAgent, can you help me in finding this? Now, what is going to happen now is GeoAgent is going to tap into its resources and see what it has available. And in this case, it knows that it has a material identification workflow available to it. So of course, it's going to walk through how it can accomplish this process. It can, in this case, say it needs to find a relevant spectral library, and then it's going to find a raster and the vector mask for the actual mineral detection workflow. So we're going to go ahead and say, yes, I want you to proceed. Yes, please search a particular library. So I think, yeah, okay, perfect, there we go. So what I just did essentially is, if you are an ENVI user and you are in the world of material identification or spectral analysis as a whole, you probably are aware that ENVI has access to thousands of spectral libraries included within it, of course, collected from industry. GeoAgent can parse through this list with the context and the understanding of what you're telling it. So in this case, it knows that if we're looking for neodymium, we need to use a basin-site spectral library, excuse me. What's also interesting about what you're seeing here, and actually maybe we can just talk about this. What's actually interesting about what you're seeing here is that GeoAgent is, because it's using a large language model behind the scenes, you can use it as a training aid too. So you can ask it, why these type points? As an example, and it'll give you some context as to why you're using those type points. So we've seen a lot of feedback from people that actually are able to understand. Sorry, let me rephrase that. A lot of the feedback that I think is resonating with people is using AI to help minimize the time it takes to accomplish workflows by minimizing time for analysts to understand what the problem they're solving is. And that's one of the things that I think we can enable with GeoAgent. So with that said, I am happy with those continuum type points with the context that it's given me. It's talking to me about the actual wavelengths and what they correspond to, and therefore it recommends that we do this with these type points. So let's go ahead and say proceed with processing. Now it's going to go ahead, yeah, there you go. It's executing the processing. You can see that there's a progress bar that pops up at the top. Now, I want to caveat that right now, this processing is only as fast as the environment that GeoAgent is living in, or in this case, the ENVI tasks, the ENVI processing node is living in. So this will probably take, if I had to guess, maybe 2 minutes max. But some of the other things that we can talk about with GeoAgent is, you can look on the left here, but the multi-language support that we almost get for free by integrating with a large language model is we saw that there is a interest in people that use ENVI in English and maybe they're native speakers in a different language, and being able to interact with a tool like GeoAgent in your native tongue and execute processing is a game changer for a lot of people. And it's a really exciting capability that we're excited to present with the ENVI ecosystem and what we can accomplish. So let's see how processing is going here. I don't see the progress bar, so that means it's still going. One other thing to mention here is we're really just kind of showing a different way of working with remotely sensed data, right? So the threshold that it picked of 0.58, you can adjust it. So if I was in ENVI, it would be just like adjusting a parameter in a workflow. So point being, it really is a difference in user experience, but the end goal, I think, is what we care about, right? And here you can see that GeoAgent was able to find those rare earth elements, right? So what you're actually seeing here is GeoAgent took your target mineral against that reference spectra, and here's the detections. It then ran through multiple tool chains to essentially create shapefiles out of those detections, and then that's what is being served to us right now. We have detections over the open pit mine. We have some detections over deposits around the area, and then it looks like what's possibly detections over maybe just foot traffic, vehicular traffic around the area, things like that. But either way, I feel good with these results. So we within our ecosystem are obviously, we coexist with a lot of other product ecosystems, and that's kind of what I was getting at by that whole vendor agnostic tying into your workflows component. So what I wanted to highlight is that I feel happy with these results. So why not just take these results and push them to an environment that I'm already working with to upload all of my data. So we can just call them ENVI Webinar 3, something like that. And essentially what's going to happen now is it's either going to prompt me to confirm, or it's just going to go ahead and ask me, and it's going to go ahead and proceed with uploading to our GIS Online. So we can now take our outputs from GeoAgent's user interface here. And you can see that GeoAgent actually serves a link as well. So it did say it successfully published the results to our GIS Online. So let's see what that looks like from their end. So now that we are here within the AGOL ecosystem, we can see that the name carried over. We're looking at ENVI Webinar 3, which was that detection layer that we just processed with GeoAgent. And let's visualize that layer, see if we can gather any more context with it. And so if you see that the layer came in, I can click on that and I can look at the attributes and see if they are correct. But what I think is more lucrative and what's really exciting to me about this is I'm not an ArcGIS AGOL power user, but we have people that are. So in many flows, there are people that GeoAgent is helping open up doors for. So now somebody that is an AGOL proficient analyst can enrich this data further. They can do further analysis with it. They can bring in other layers, so on and so forth. So the GeoAgent story is a really exciting one for our business, I think. I think AI is very transformative in many ways, and we're excited to see where we can take AI and connect it to geospatial problems. With that said, Zach, back to you.
All right, sweet. Let me steal screen share back, and we'll talk about a couple of things before we hit our conclusion. So maybe, one other thing to kind of just state real quick, it's like kind of the theme today is how can we connect people with relevant information, and that's kind of happening on two fronts, right? We've got the ENVI and IDL Repository, where we can take content that you can then bring to other users, where even if they're not experts, they can access, download, and run those workflows within ENVI without having to manually install or put files somewhere. And there's the same or similar kind of story with GeoAgent, like Khalil said, where if you're not an expert at remote sensing or creating workflows or ArcGIS Online, AI can be a great stopgap to help automate and do those things for you so that you can spend your time on what's important and maybe stuff that you don't care about as much. So I think Khalil's spot on with the transformative aspect of AI. But getting to our closing slides here, since we're right on time. So we've talked about pivoting back to kind of our desktop software and repository. We had 5 different pieces of technology that we were actually showing today. So 3 things are available right now. So if you go to our downloads portal, you have IDL 9.2, ENVI 6.2, and machine learning for ENVI 6.2. All those are you can download and utilize right now. ENVI 6 or machine learning for ENVI 6.2. This used to be inside of the deep learning module, it's now included with the ENVI download. So when you download ENVI 6.2, you'll actually get a zip file that has machine learning bundled with it. So that should make it easier for all of our ENVI users to have access to machine learning. The repository server is getting wrapped up right now. We need an extra week or two to tidy things up. So at the beginning of September is when we should hopefully have everything together, and will also be available for everybody to install and utilize the repository workflows that we showed. ENVI Deep Learning needs a little bit more time in the oven to cook. So we're looking towards the end of Q3 or early Q4, more likely, where that will be wrapped up for everyone to access. So lots of technology, but this is kind of our rough timelines when some of the parts and pieces will be here. And I think with that, we can maybe jump to the Q&A section. And I don't think I have audio issues this time, Khalil, so hopefully we'll be able to ask questions.
Yeah, let's see here. So I assigned a question to you regarding the repository. I think you can see on your end. Okay, yeah, sorry, I'll let you read it out loud, sorry.
Yeah, so the question, we'll translate a little bit here, is that we have a user who's worked with some of the IDL specific framework for creating ML models. The ML models that you work with in IDL are not ONNX, but you can still use them within IDL and the repository as IDL packages. They are not something that can be exported to another framework or utilized elsewhere like Python. If you wanted to use those IDL ML models from Python, you would need to use the IDL Python bridge behind the scenes. That's how you would be able to set that up. So let's see here. I have one question for you, Khalil. Is there any connectivity of GeoAgent for other data catalogs?
Yeah, so in the phase 2 approach, which is actually we're in right now, we're in a big requirement discovery phase. And one of the core requirements that we needed to make sure that we are compliant with is being compliant with stack-based catalogs. So by starting with that hardened requirement using stack-based catalogs, I think it'll actually help enable us to integrate with more external catalogs down the line. So that's about as much as I think I can probably share right now. But some target catalogs I think would make sense, things like Earth Explorer, those open source catalogs that we know are beneficial to a lot of people.
So it looks like there's maybe another one about repository. So we got a question of what's the repository server software? How do I create a server? As I just mentioned on the last slide, we're actually going to be releasing a standalone installer for the repository that you'll be able to download and set up yourself. It'll have a guide with it for how to do things like backups, restorations, make sure, because you'll be putting important data there, that all of that persists. And that'll be something that anyone will be able to access from our downloads portal once it's posted here in a couple of weeks. I think we've maybe got time for one more. I think maybe a good question is, do I have to purchase anything else to utilize the repository? The answer for that is no. The repository is included with ENVI 6.2 and IDL 9.2. You just have to download and install the server yourself. So in order to utilize that, you do need ENVI 6.2 and IDL 9.2, so it won't work with previous versions of ENVI or IDL. But yeah, I think that's good. We are right at 1 o'clock. So yeah, thanks everybody for joining. And we will send out a recording and a copy of the slides here within a couple of business days. If there's other questions, feel free to reach out to us, or if you have an account manager that you work with, they can also route questions to us as well. So thank you everybody for your time, and we'll catch you later.